In this video, we evaluate the limit which is of the type n expression to the power another. Observe that as x tends to 0, 10 pi by 4 plus x tends to 10 pi by 4, which is 1, whereas pi square by x tend to infinity. So it is of the type 1 to the power infinity, and we do not see any standard formula to evaluate this limit. So what we will do is we will apply L'Hopital rule or L'Hospital rule. Let's do it. Even if we want to apply L'Hopital rule or L'Hospital rule, we need either of the type 0 by 0 form or infinity by infinity form. However, we do not see such a form. So what we will do is we will let y equal to this expression. Now we take log on both sides because we got exponent and we know that logarithm are the inverse of the exponent. Once again, we got y equal to this expression and we take log on both sides, log on the left hand side and log on the right hand side. Log has a property that we can take power out of the logarithm. We got power of pi square by x and we can take this power out of the logarithm. So we will get the expression pi square by x to be multiplied with log of 10 pi by 4 plus x. What is the advantage? Well, advantage is that as x tends to 0, 10 pi by 4 plus x tends to 10 pi by 4, which is 1, and log of 1 is 0. So it is of the type 0 by 0 form, and we can apply L'Hopital rule. Once again, we got log of y equal to this expression, but we don't get the limit, so let's take limit on both sides. Once again, we take the limit both sides. We got two equal expressions. So if two expressions are equal, their limits should also be equal. Limit x tends to 0. We want the limit as x tends to 0. Once again, limit x tends to 0. Now you can see that numerator is tending to 0, denominator is also tending to 0, so it is of the type 0 by 0 form and we can apply L'Hopital rule. If we want to apply L'Hopital rule, we need to get 0 by 0 form. We got it 0 by 0 form and we need to evaluate the limit as x tends to 0 or whatever be the number. But when we got L'Hopital rule or we want to apply L'Hopital rule, what we usually do is we simply differentiate the numerator and differentiate the denominator and compute the limit, and if we are able to compute the limit, we say that that's the limit. That's the beauty of L'Hopital rule or L'Hospital rule. Obvious question is, can we compute the limit by differentiating the numerator and then differentiate the denominator? You see that when we differentiate the denominator, derivative of x with respect to x, that is just 1, no problem. Pi square is a constant, so we don't have to worry about pi square. Derivative of log of u is 1 by u. So 1 by 10 of pi by 4 plus x. And then we need to differentiate u as well, or 10 pi by 4 plus x. Derivative of 10 pi by 4 plus x is sec square pi by 4 plus x. Fine, we did apply L'Hopital rule, and obvious question is, can we compute the limit? The answer is yes. Pi square, that's just a constant. As x approaches 0, 10 pi by 4 plus x tends to 10 pi by 4, that we can compute. Sec square pi by 4 plus x tends to sec square pi by 4, that also we can compute. We know that sec pi by 4 is root 2. Pi square we write as it is. Sec pi by 4 is root 2, so we get root 2 whole thing square. 10 pi by 4 is just 1. That is equal to 2 pi square. Okay, we got limit x tends to 0, log of y equal to this expression, which turns out to be 2 pi squared. But the question is asking for the limit x tends to 0 of y. We know that log and exponent are inverse of each other, and in case of continuous function, we can just compute the limit. As exponents are continuous function, we can say that this limit is equal to limit x tends to 0 y is equal to e to the power 2 pi square. Why is it so? Because if f is continuous, as x approaches a, fx must approach f of a.